Yes, today we're going to do chapter 5, section 4, properties of logs. So we're going to go through all the properties first. First property is called the product rule. Remember, okay, first off, let's review. We first talked about exponentials. Exponential functions, which look like that. That equals some number y. Then we talked about logarithms, which look like this. You notice that the bases are the same. These are both base A, here and there. Because of that, how these are related, this is actually the inverse. The logarithms are actually inverses of exponentials. So they're inverses of each other. The conversion from logarithmic to exponential the conversion. So the base has to remain the base. So it comes over here and pushes up the y. And since the base is gone, the log drops off and we're just left with x. So this is the exponential and this is the logarithmic. So that's how you convert them. If I give it to you this way as an exponential, you have to put it in this way. So the answer becomes the operation, the base remains the base. That's why it's the inverse of each other. All right, the first property, the product rule. We have log base A of m connect so it's log base A of m times n, where m and n are equations. Because they're making, when you multiply things, it gets bigger. So what we do here, we can convert it to the sum of the two. So that's the product rule. The product means multiplication. It converts to addition. The second rule is called the power rule. When you deal with logarithms, you cannot have exponents. So whenever you have an exponent, that just goes out in front. That's why it's called the power rule. The third property is called the quotient rule. The quotient means fraction. So if we have the log base A of a quotient, when you divide things, you make them smaller. So this is what becomes subtraction. Whatever's on top goes first, whatever's on the bottom goes second. More importantly is whatever's on the bottom will have a negative coefficient in front of it. If there's no if it's a positive coefficient in front of the log, then it's on top, or if there's no fraction. But if there's a negative in front of it, then you know it's a fraction. All right. we have the other logs that we talked about last time. The base 2 logarithmic exponent. So if we have a base raised to a log with the same base, that equals the operation. So this is a to the power. Remember, if it's an exponent, this is the base. Well, that's also the base. If they're the same, it's whatever the operation is. And the fifth one is logarithm of a base to a power. And this is the one we did last time. What this one says, it's x. Now, the reason this one is x is because of here. You can't have an exponent, so the exponent goes out in front. And last time, we talked about this one. This is number 6. Log base a of a equals 1. If the base and the operation are the same, it equals 1. So since that equals 1, all we're left with is x, which is why that property stands. And the other one we talked about last time, log of 1 is always 0. Those are your 7 properties of logarithms. Now, very important that we have to be able to go both directions. We have to be able to go both directions. If I give you log m minus log n, I can rewrite it as this. If I give you n log m, you can write it as this way. So just because there's an equal sign there, it doesn't mean that it's only that you can only go this way or that way. You can go both directions. All right, let's look at the examples. The first example. Express as a sum of logs. Our equation is log base 3 of 9 times 27. So since it's a product, we use the product rule. So we can rewrite this as log base 3 of 9 plus log base 3 of 27. This is all it asks for. But if you can go further, try to go further. Let's convert this to a number. Log base 3 of 9 equals some number x. Converted to exponentials. So that becomes 3 to the x equals, because the log drops off, equals 9. 9 is 3 times 3, so it's 3 squared. Since the bases are the same, the exponents have to be equal. So x equals 2. So this first one equals 2. Log base 3 of 27 equals some number. Same thing, convert it to exponentials. The 3 pushes up the x, the log drops off, equals 27. 27 is 9 times 3. 9 is 3 squared. So this is 3 times 3 times 3. Since we have the same bases, x equals 3. So in short, however, if it just wants the logarithmic equations, this is your answer. If it wants the final answer, that's your answer. In other words, if you can go further, always go further. Example 2. Express as a single log. Log base 2 of p cubed plus log base 2 of q. Well, if it's a plus, from the product rule, we start from this side. If it's a plus between there, then we can combine them to be a product. Especially because it has to be the same basis. So this is p cubed times q. And there's your answer. Example 3. Express as a product. We have 3 of them. First one, log base a of 11 of -3. Log base a of 4, the 4th root of 7. And ln x to the 6th. So expressed as a product. Well, the only thing we can do here, you can't have exponents. So that's all we can do here. And that's your answer. It's a product of -3 times log base A11. Let's do C first, because we'll have to explain this one. You can't have exponents, so it goes out in front. And there's that answer. Now, the middle one. When we talked about radicals a long time ago, we learned the rule, the formula. Where this number here is called the root. We can convert this symbol to an exponent. Whatever is inside there goes on top. The root always goes on the bottom. That's the root of a tree. It's on the bottom. Even if we had something like this, this would still be written as 2/3. Because that number has to go on the bottom. Whatever is here goes on top. And also remember that if there's nothing there on top of it, there's automatically a 1. So the first thing we have to do with this example on B is we have to convert it. And take it out of the radical. So it's a 7. This is the root. It's a 4, so it has to go on the bottom. And there's nothing on top of the 7, so it's a 1. So the exponent goes in front. And both of these are the right answer. Because if you have a fraction in front, it's multiplication. 1 times log a base 7, 4 times 1. So you can represent it both ways. Example 4. The difference of logs. Log base t of 8/w. Since this is a fraction, I have to use the quotient rule. Whatever's on top goes first, minus whatever's on the bottom. So it's log base t of 8 minus log base t of w. And there's your answer. Express this one as a single log. Log base b of 64 minus log base b of 16. Since we have a minus, that means this one has to go on the bottom. And they're both log base b. So they're both log base b. Since they have opposite signs, the positive one goes on top and the negative one goes on the bottom. And we can go a little bit further with this. 64 divided by 16 is 4. Example 6. As express these as sums and differences of logs. Here's the first one. Log base a of x squared y to the 5th z to the 4th. The question usually asks is, where do you start off? Well, since if you look at it, the first thing you see, it's a fraction, we use the quotient rule first. So take the top, leave it alone, minus the log base A of the bottom. Then we see a product here. We can't have a product. So that, because since they're multiplied, we use the product rule. So it's the first one plus the second one. Since you can't have exponents, those all have to come in front. This is 5 log y minus 4 log base A of z. And that's your answer. Look at the answer and then look at the original question. You see how they're related. Coefficients become exponents. The 5 goes on top of the y, the 2 and the x, and the 4 and the z. If it has a plus in front of it, then they're on top. If there's more than one, they multiply. If it has a negative, it goes on the bottom. And if you have multiple negatives, then they all go on the bottom. The next one, log base A of the third root of A squared B C cubed, or C to the fifth. The first thing we have to do is get rid of the radical. So it's A squared B over C to the fifth to the power 1/3. And remember, a long time ago in chapter 2, in chapter 1, we talked about whenever you have a power to a power, you multiply. Whenever you have a power to a power, you multiply. So here we have on top, we have A to the power 2 times 1. 2 times 1/3 is 2/3. B has nothing there, so it's an invisible 1. 1 times 1/3 is 1/3. On the bottom, we have C to the fifth divided by 3. That got rid of the radical, and that got rid of the parentheses. Now, the top, we have well, the whole thing is a quotient, so we just do that first. So we have A to the power 2/3 times B to the 1/3. Since C is on the bottom, it's a minus. This is a product, so I gotta split those up. A to the 2/3 plus log base A of b to the 1/3 minus log base a of c to the 5/3. Can't have exponents, so they come out front. We have 2/3 1/3 and 5/3. Are we finished? Why not? Very good. Log base a of a is 1. So the first one's only 2/3 plus 1/3 log base a of b 5/3 log base. There's your answer. Very good. Ready for the next one? Okay, so let's see the third one. Log base b of a y to the 5th m/3 n/4. This is one equation. With practice, remember, since we have a fraction or a quotient, more likely, we could just jump. There's a shortcut we can do automatically. Remember I said earlier, if it's on top, it has a plus in front of it. If it's on the bottom, it has a minus in front of it. So what we could do is log base b of a plus log base b of y to the 5th minus log base b of m to the 3rd minus log base b of n to the 4th. If it's on top, it just has a plus in front of it. If it's on the bottom, it has a minus. No coefficient there. There's a 5, so it goes out in front. There's a 3. And there's the 4. And that's your answer. Or if you wanted to, you could have still, well, before we do the next one, let's do this one the other way we just did. Let's do that one again. Let's do that one again. Example 6C again. Log base b of ay to the 5th m/3 n/4. We see it's a quotient. So we have the top first minus the bottom. In the first one, it's a product. So we add, do the sum of the two. There's a minus sign in front. And this is going to be also add. So we put that in the parenthesis because we have to do the operation here. Now distribute that negative sign to both of those inside there. So it's negative log base b of m cubed. Negative times positive is a negative. Log base b of n to the fourth. And the last step is get rid of your exponents. Log base b of a, 5 log base b of y, minus 3 log base b of m, minus 4 log base b of n. Both ways work. One way is a lot faster than the other. All right, let's look at example 7. It says, as a single log. Five log base b of x minus log base b of y plus 1/4 log base b of z. What do you think the first thing is going to be is what? Get rid of the coefficients. Because we can't do the subtraction multiplication yet because we have coefficients. We have to get them, so it's just log in a number. So that becomes an exponent. This becomes an exponent. So it's log base b of x to the fifth, log base b of y, plus log base b of z to the 1/4. We have a fraction up here. What does that mean? What's it going to be? It's going to be a radical. Yes. What root? Very good. So this one is going to equal the 4th root of z. Log base b of y plus log base b of the 4th root of z. Now we can combine them. Since we have pluses and minuses, that means we're going to have a fraction. And they're all log base b. So it's log base b, and it has to be a fraction. Anything that has a plus in front of it goes on top. Anything that has a minus goes on the bottom. So x to the 5th, 4th root of z go on top. And y goes on the bottom. And there's your answer. Example 8. As a single log. ln 3x plus 1 minus ln 3x squared minus 5x minus 2. What does ln mean? What base is that? So ln of x is log base e of x. It's a natural log. So what do we do with this one? What do you notice in front of the logs? What is this one, positive or negative? This one? So if you have a negative, automatically means what? You have a fraction, right? So it's ln can be a fraction. Whatever's positive goes on top. Whatever's negative goes on the bottom. Since we have a quadratic on the bottom, we have to factor it out. Because you want the equations to be in their simplest form so you can see if anything cancels. Since the leading term is 3, it's 3x and 3x. The second sign's a minus, so it means opposite signs. And the bigger number gets the negative. Take the first and the last term. 3 times 2 equals 6. We have to figure out what two numbers multiply to equal 6. When we subtract them, it equals 5. Six times 1, 6 minus 1. Very good. And since the first sign's a minus, the 6 goes to the minus. Can you factor anything out of the first one? No. 3 and 1 are prime numbers. You can't factor anything out of the first one. Does the second one have anything you can factor out? A 3, right. So if we divide both of these by 3, all I get is x minus 2. Erase that 3 we factored out. So what we have now is on the bottom is 3x plus 1 times x minus 2. Can anything cancel? So what's our answer going to be? No. What's our final answer going to look like? Well, yeah, we just use these guys. It's not going to be x minus 2. Why not? Because where is x minus 2 right now? On the bottom. It has to stay on the bottom. You can't move it on top. In other words, if it was 1/4, you can't make it 4. So because x plus 3x plus 1 goes into 3x plus 1 time. So we have 1 over, this is your answer. Because of our graph, what's our domain here? What does the graph of a logarithmic function look like? This is an exponential equation. If we flip it across this line, the y equals x line, then we'll get this graph. That's the ln of x. The domain is it cannot equal 0 and it can't be negative. So x minus 2, set that equal to 0. So x cannot equal 2 or anything less than 2. That's my domain. Because anything less than 2, you have a negative on the bottom, and you cannot have a negative. Example 9. Okay, we're going to say that log base a of 2 is equal to 0.301. And log base a of 3 is 0.477. Those are we're defining those at. Let's find the following. Log base a of 6. So obviously, what we have to do is we have to rewrite this number into 2s and 3s. So how do we do that? Not add. Well, what equals 6? 2 times 3, right? Now we have a product rule, which says log base a of 2 plus the log base a of 3. We first have to go to the product rule, and then from there we can use this summation. That's probably what you meant. Log base a of 2 is 0.301 plus 0.477. Add those together, we get 877.0. Yeah. B is log base a of 2 over 3. This is a quotient, so we use the quotient rule. Log base a of 2 minus log base a of 3, which is log base a of 2 is 0.301. Log base a of 3 that one's going to be negative. So we have 0.477 minus 0.301 is 0.176. Let's look at C. Log base A of 81. Remember, all we have are log base 2, log base A of 2, and log base A of 3. How do we do that? So how do we write 81 as a number of both of those? One or both. Well, what is 81? What is it made up of? 9 times 9. 9 is 3 times 3. So this is made up of 3 to the power 4. So this is log base A of 3 to the power 4. The coefficient goes out in front. The exponent goes out to be coefficient, I mean. And log base A of 3 is 0.477. So we multiply it by 4. $1.908. Log base A of 1 over 4. So we have log base A of 1 minus log base A of 4. Four is made up of 2 times 2, so it's 2 squared. So it's log base A of 1 minus log base A of 2 squared. Log base A of 1 is what? 0. So that's gone. So we have negative, bring the 2 out in front. So it's negative 2 times 0.301. The answer is going to be negative 0.602. And there's that answer. How about this one? Log base A of 5. Do we have any rules? How can we do 5? Well, the only thing with what we have, we can say 2 plus 3. But are there any rules that say we can take the log of something added? No. So that's as far as that one goes. There's no property that says we can expand that. Log base A of 3 over log base A of 2. Log base A of 3 is 0.477 over 0.301. And whatever that number comes out to be on a calculator, that's your answer. But always keep that formula sheet, the property sheet next to you. So whenever you do these. Example 10. Log base A of 8, 8 to the 8th. What's the answer? Very good. Because remember, well, besides there being a rule that says log base a to the power x is x. If the bases are the same, they cancel. What happens is this 8 goes out in front. Log base a of a is 1, so it's just 8. ln e to the power negative t. The answer is negative t. ln is log base e. How about this one? Because if there's nothing, no base, it's automatically a base 10. It's called the common log. This is the common log. This is a natural log. Simplify each of the following. How about this one? Because this is the base and that's the base. If the bases are the same, they cancel. E to the power ln 5. Yeah, because it's E ln is log base E. So it just equals 5. Ten to the power log 7t. Because remember, if there's nothing there, log 7t is log base 10 7t. All right, let me go over some common errors that people do with logarithms. The first common error, log base a of m times n is log base a of m times log base a of n. That's not true. Log base a of m plus n, log base a of m plus log base a of n. That's also not true. You cannot take the log of a sum. You can't split that up. The quotient rule, log base a of m over n is not the same thing as log base a of m over log base a of n. That's not the same thing. log base A of m to the power, the whole thing's to the n. That's not the same thing. If the log is inside of parentheses raised to a power, you cannot do the power rule. That's the end of section 4. Let me stop this so we can do